Hello, am I clearly audible? Yeah,
Yes, you are audible.
yeah, that's fantastic. Good morning, everyone. Thank you for tuning in, that too on a Sunday morning as per Indian Standard Time, for this online invited talk, and we hope to have an informative and fruitful session ahead of us. Speaking just a little bit about our club, Astronova is the student-led astronomy club of Institute of Radiophysics and Electronics, IRPE, University of Calcutta. We are a group of motivated and curious individuals who share a fancy for all that the cosmos has to offer to us. Astronomy Sundays is a series where we bring forth and interact with experts in the field of radio astronomy, astrophotonics, cosmology, and related fields to gain some valuable insights and spread the word about these fields of study. Today's session, Albi, has a slightly different flavor than usual and is primarily centered around space robotics. To introduce our beloved speaker, Mr. Ashutosh Mishra is a doctoral researcher at the Space Robotics Laboratory, Tohoku University, Japan. As a recipient of the prestigious Japanese MEXT Scholarship, he is dedicated towards advancing research in space robotics. Alongside his doctoral studies, he serves as an innovation ambassador for the Ministry of Education's Institution Innovation Council, IIC, promoting innovation and entrepreneurship among students and researchers. His current research focuses on the development of advanced robotic systems for space exploration, particularly working on the Japanese government Moonshot Goal 3 program for self-evolving AI robot systems for lunar exploration and human outpost construction. Without further ado, let us start today's session. Sir, the stage is all yours.
Greetings, everyone. First of all, I'm very grateful to Astronova for inviting me, and I'm really very happy to present my thoughts and share the space robotics fields with young generation. So I'm sharing my screen now. Is my screen visible?
Yes, it is.
Okay, so starting with the you already introduced me. I'm currently a doctoral researcher in Space Robotics Lab, Tohoku University. So today context is to talk about emerging lunar robotics fields and the experiments which are going on around the world. We have seen that there is a renewed interest in lunar exploration around the globe. We have seen the NASA Artemis program, Russia, China ILRS program to habitat the lunar surface. We also have individual programs like India's Chandrayaan project, and we have China's Chang'e project and Russia's Luna series. So, in this current situation where everyone is targeting moon and space exploration, how what's the role of space robotics? I believe that it's very essential. Space robotics plays very essential role in that maintaining and constructing various habitat and exploring the space environment in the very harsh climate. So why we use space robotics to explore these things? Because the main reason and obvious reason is that we humans cannot go directly to an unsecured or extreme environment and test out on ourselves. It's better to send some robotic equipments, measure the radiation and other aspects of that environment, and then we can just after so many hit and trials, we can just design some space suits and other things for that, so that the human presence can be survive on that particular environment. And also, apart from safety, it is very efficient. It reduces the human risk, and also we can control remotely and do various other tasks. So, space robotics plays a very significant role. There are, like, you can do resource extraction. There are minerals. There are valuable metals and other resources out there. There are companies like there are companies in US which are targeting asteroid mining to bring the space-based resources to Earth to meet the human need here. We can use space robotics to build infrastructure development. Like use Elon Musk is very much in the talk that he wants to build human civilization on the Mars. But how is he is gonna do that? With the help of space robotics only. Robotic labor in extreme environment plays a vital role to build habitats and other communication networks. And of course, the scientific exploration is also one of the context. We get to know about our history, our space, very much through this conducting through this experiments. You can consider the Aditya L1 mission or NASA's Perseverance rover mission and other missions to explore the space, because there is always curiosity in the human mind to explore the unknown things. And it also extends our human capabilities and it tests our intelligence. And apart from that, space robotics is very cost effective. It it reduces the need of frequent human missions and provide our sustainable presence on apart from Earth, on other planets and in space. So I will try to bring you closer to space robotics field through my own space robotics lab experiments. We have a diverse experiment set up to target different challenges we face in space. So the research areas of Space Robotics Lab, you can broadly classify into small satellite development, microgravity robotics, exploration robotics, and terramechanics robotics. There are different labs also, but I will be focusing on these four mainly. So small satellite development basically used for communication, establishing communication links and doing in-orbit experiments. Basically, these are like getting the input data, solar radiation, and other stuff. Like recently, JAXA launched the ADOS one and other satellites, so that will come in this category. Then the second category comes to of like microgravity robotics. It's like in orbital robotics, how you grab things in space because everything is moving in various directions, having various vector forces applying on that. And due to that, we will talk about this, how you can grab objects and do various robotic maneuvers in orbit. One of the famous example is the Canada arm on the ISS, International Space Station, which is used for docking, ejecting astronaut garbage in space, and other maneuvers which is impossible without it. Then the third category is exploration robotics. Here we've built small robots and medium-sized robots. Currently, we are developing a human size also. So basically, these robots are meant to explore the unknown environment using latest technologies like computer vision, SLAM, and other things. And then comes the terramechanics. Like space robotics is not all about electronics and robotics thing only. It's the study of how your robots will survive in unknown environments. So terramechanics field, our terramechanics lab will discuss basically deals with the interaction of sand, soil, gravels on lunar surface and or asteroid surface, and its interaction with our robotic wheel or legs. So what we are targeting, we are, if you consider the case of moon, we are targeting the very fine sand. It is very problematic because it infiltrates the circuits and other things and even blocks the vision camera system, creates a hurdle in computer vision algorithms. And also your wheel, your leg gets sunk into the sand, which then affects your mobility. Then you have rocks, gravel, hilly areas, which basically affects the rover in many ways. The wheels are cracked. You can see the Perseverance rover wheel is cracked now due to continuous traveling across decades. And definitely how our robots will survive in vacuum, heat, and other radiation aspects. So coming towards the exploration robotics, we can divide into two tasks, like wheel robotics and the leg climbing or leg or climbing robotics. So we are developing these mobile robots and also the climbing robots for extreme environment. Basically, the climbing and leg robotics is used where the wheels are ineffective, and like you can experience or you can encounter a crate on moon. So how you will uh, avoid it, or how you will just go through it, or you can just get familiar or some rocks in front of the camera or a huge something. So you just need to climb to explore that particular area. Also, these mobile robots are enabled with corporative exploration. You cannot expect that a single rover will move around the lunar surface and map all of the things. So we need a group of rovers to map different directions and create a collective map and provide the details of the whole exploration. The benefit of this method is that this cooperative method is that you get the view of a whole large area in a very short time, as each robot is going in different direction and providing the data to a central system. And also it's very time efficient. So for corporative exploration, we use simulation environment first. We use SLAM algorithm to map the area. We also use obstacle recognition in that. And then after getting into one of these fields, we integrate them to make it more autonomous exploration robot. So here you can see one of the robot that's very small. I think it's not visible, but it's exploring within this area grid system with avoiding these obstacles, rocks, and mapping the whole environment. Coming towards terra mechanics, so this is one of the NASA image. You can see the wheel is stuck in the sand and it cannot come out. And similarly here, the robot is unable to climb up on the hill because the wheels are getting stuck and the sand is getting collected by the continuous rotation of the wheel. So we need to see how slip suppression or stuck idling we can avoid. So these are the one of the issues I'm talking about, but there are many others which terra mechanics field deals with. So I will be diving more into the wheel aspect, like how we mitigate these things. We basically use sand flow analysis. There are various methods. One of this particle image velocimetry, and then other is discrete element method. So in this simulations, we consider each particle of sand to an individual elastic body, and then we compute the collisions and other force and friction with in continuous arrangement with other particles. So it's very heavy simulation. It takes weeks or may take more than that to just simulate a few centimeter of movement, but we get some like this. You can see these arrows. These are just providing you the direction and the movement of the soil, basically the interaction between this wheel and this soil. And then we have other simulation which shows how these particles or the sand is being affected by the force of the wheel while rotating. So basically this gives us visualization, which is very important to design the end effects of these wheels. You have seen that there are wheels which are straight outwards, these fingers. Some are diagonal, some are round, some are different. So these wheels are basically designed on the basis of these kind of simulations and study. And it gives a quantitative evaluation of wheel performance. So after the simulation, we also have some sand bed. This is the replica of moon sand in our lab. And we have a physical wheel, and then we compare the simulated environment with this practical environment. And even with the trace it will form on this, we can study how deep it has went into the sand and what is the slip ratio, how much it's slipping, and other things. Why slip ratio is important? Because suppose we have a rover which is having four wheels, and it may happen that all the four wheels are slipping, and it may happen that only one wheel is slipping. So how you mitigate that thing? You just measure how much distance you have traveled and how much, like, the velocity you expected from the wheel and what you are getting right now, and then you subtract that, and then you detect that there is a slip, and through these studies we then mitigate those slips. So this slip example can be applied to your car systems also. There is a ABS system in every car, which you can which avoids slipness on snowy surface or wet surface. If you turn it off, it slips more. If you turn it on, it slips less. So this is how it works. They just reduce the or increase the speed of the wheels with proportion to the slip ratio they get through calculations. So talking about climbing robotics now, actually this is very challenging thing because you want to climb the mountains, the craters on the moon, and avoid the falling of the robot because it will damage it, and at the same time you want a maximum grip. But for maximum grip you need more power, and for more power you need more, like, if you need more power your size will increase, and then maintaining the position will be more difficult. So it's very difficult. Extreme robotics is very difficult here. So this is one of the gripper example our lab has developed. So it has a few fingers, there are 6 fingers, 3 axis free joints, palm, wrist, and a passive, we call it passive spin gripper. And we have a lot of different grippers. This is one of the example. So in space robotics, study of how you grab things is also important. And by analyzing different grip patterns, we then create the robots for climbing. So after finalizing the gripper, we just integrate with the other robots and then do the experiments. So this is Hub Robo in our lab, which is 1.6 kg. It has 6 legs and 3+1 degree of freedoms, and it can climb slight elevations. So it should it's not a video. I meant to add a video, but it's not working. So here you can see it's climbing some hard inclination here. Coming towards the Moonshot project. So Moonshot is the project recently launched by the Japanese government. They target to Moonshot project is having many goals, and one of the goal is to habitat the lunar surface by year 2050. So my professor is in charge of this currently project, and this project is currently having 3 main tasks. Like, we need modular and reconfigurable heterogeneous robotic system, then we need a transferable AI system, and then we need on-demand robot design or on-site fabrication. So combining the experience from other 4 broad labs which we discussed earlier, we are now planning to go to the moon and establish a habitat zone for humans. And for that, we are currently focusing on modular and reconfigurable robots. Now the question arises, like, why we want to why we want to do modular, not why we cannot make big robots and send it to the moon directly. Because of the cost, first of all, like sending a big robot, it will take more space, it will take maybe it can break while going up, or the repair cost is too much, you need to repair everything. For modular robots, that's not the case. You can just remove that particular part which is removed, which is creating the error, and then what you can do, you can replace it with a new one. Modular robots also provide a path for us to make robots assembly on the moon, and we don't need to carry the manufactured robot from Earth. We can just transport the things there or do the assembly with one robot assembling other robots. So that's the concept of Moonshot Project Goal 3. Then we are talking about transferable AI systems. As you know that AI system takes, like as a whole, if I say, it takes some input, then processes it, and then train a model. But if you have modular robots, then this process is quite difficult because the parts can change. This leg can be removed and a wheel can be attached depending upon the problems you face while exploration. So that's the benefit of more modular robotics, that you can explore environments with the same robot, or you can evolve your robot on the lunar surface depending upon the task which it encounters through its vision system. So you can see we remove the leg and then attach the wheel, or maybe we attach multiple bodies together, or maybe above it, not in sequence but vertically. And with the same modular parts, we can do different things. The climbing robot, the transportation robot, the communication tower. With the same modular components, we are planning to build the whole robotic ecosystem there. And for that, a AI system, modular AI system is needed where the skill transfer can happen within the modules. And you all know that if we are planning to go to moon or Mars, we need some 3D printing or some fabrication process which utilizes the regolith on the moon to build structures for humans and these robots. So as I discussed that these modular robots are the interchangeable modular parts are compatible with one another. We can combine different parts to make different configuration. They are versatile, robust, and adaptive to other things. And these are just illustrations due to confidentiality. I'm using illustrations, but if you visit somehow our lab, we actually are having now a human-sized modular robot upon which we are doing some experiments. And maybe we will release some publications in near future. So for getting you the idea of modularity, I have taken this snip, this GIF from Disney Robotics. So you can see there is a one control system. You can attach the leg. Even if one of the leg is break, it just finds the motion to walk in a particular direction or do the exploration task. Even if one leg is failed or two leg is failed, it keeps on moving unless it has one leg. So this is kind of not this kind of, but more advanced kind of modular robots we are trying to build. So I have talked about all the contemporary work which are going around the world. Like the Japan is having its moonshot project for habitation of moon. The China is targeting moon. The Russia, USA, NASA, everyone is targeting moon right now. There are private companies also like Intuitive Machine, which are building landers. iSpace is there, and they plan to bring. They plan to transport back into to Earth and Moon. Now SpaceX is also in 2026. There is a mission planned for transportation to Moon and back. So the world is shifting towards moon habitation right now, and there's a huge drift towards space exploration. So in this perspective, India's space vision is also launched recently. and India got some boost in these sectors. And the main aim of this vision is becoming self-reliant in defense and space sectors and enhancing India's role in the world. So this is the demand of the hour, and through India's vision 2047, we are basically focusing on these three aspects. There are more, but I'm covering these three aspects more. So the first one is human space flight and exploration. You must have heard about Gaganyaan mission, and in recent years, we are planning to launch our own Gaganauts in space. Currently, our Indian astronauts are in NASA JSC in Houston doing astronaut training, and it's very cool that they are getting international and NASA experience. Then we have space station development. This is the second task that in government of India approved for like building your own, like our own Bharatiya space station. And you can just Google it and you can find the images there, the proposed design for now. And then in recent cabinet meeting, they gave a nod to Chandrayaan, along with Chandrayaan, the Mangalyaan mission more, and the Shukrayaan, Venus. Now it's the first time we are targeting Venus. So it's the Indian space ecosystem is going to change too much. Apart from exploration and human flight, there is a increase in satellite technology and applications also. So government of India is focusing on advanced satellite constellations, NAVIC expansion also, and space-based internet. You must have heard that Geo is also launching space-based internet, and Elon Musk is also facing problem to launch Starlink in India completely because of the competition. And the third main sector is that to achieve all these things, we need next generation launch vehicle. So now they have a particular roadmap to design reusable launch vehicle. They recently tested the reusable shuttle, like re-entry of the shuttle and other things. We are now targeting also next generation vehicles, heavy lift launches, just like the Starship. There is a one in the program which is comparable to Starship and will be able to lift payload up to 100 ton or more than that. And we are also like have done the technology transfer, like the ISRO has done have done the SLV technology transfer to private industry so that the private can boom also. Apart from these three, we have in vision we also have strategic initiatives and collaborations. Commercialization of space-based activities is approved. We also got 1,000 crore grant for the Indian startups to target space industry. Then space security and sustainability awareness also, and one of the main aspect is defense applications. Few years back, there was news that government of India wants to change the name from Indian Air Force to Indian Air and Space Force. So that will be quite interesting that we are now thinking space as very much into defense sector also. And then we have international collaborations like global partnership with other big firms and organizations. And space diplomacy, you can see that India is doing business with China. India is doing currently, there is a LUPEX mission with Japan and India collaborative. There is NISAR project with NASA and India collaboration and other also. So India's space ecosystem is facing huge changes, and I feel that it's the best time to go into this field and build your own presence as early as possible. So thank you. Any questions? Yes. So basically, what we do, our main aim is to develop the system first. And if you must have heard about the what I say, space grid materials. There are companies and organization or different fields uh, which are working on space grade things. Like for even for a small IC chip, there is hemp for space application, which can tolerate great radiations and pressure. Sorry, great radiations and temperatures and other things. So when the whole system is analyzed for the Earth-based maneuver, then we start converting them for the space grade thing. We start replacing each component we are using or uh, uh, we are using with the space grade thing. Yeah. If you are familiar with embedded systems, there is if you bought any ICs directly, you must have seen there is some number in the end which indicates its grades. So for any IC, there are basically three grades, like one industrial grade, second is space grade, and one is normal. So it's the process is simple. We first of all just focus on the Earth-based maneuver and develop the whole system, and then we start converting it into space grade things.
Okay, sir.
Sir, I have a question.
Yes.
Sir, as we know, the first 15 days, the moon surface was very extreme temperature, lightness, and the other 15 days it is darkness.
Yes.
So, what is the condition in the union part? Means the part which is coming half darkness and half lightness, it is habitable. So, why we not targeting this area?
So
Just like
basically,
our evening or morning time,
okay,
this time.
I understood your question. So, see, if we are planning to habitat the lunar surface, we must deal with these conditions also. Talking about space robotics, we have radiation based heaters inside it. Like if you read about Changi rover, which is still surviving on the moon surface, it has that radio isotope which keeps it warm within it. And our Chandrayaan was not having that, so it didn't survive that change, the lunar night or lunar morning, which you are talking about. So in future, if we are going, definitely we are going to moon. If we are going to moon and want to stay there, in between, like change from day to night, we need these kind of systems which make the habitat warmer and maintain the same temperature and other things, pressure inside the habitat.
Thank you, sir.
Sharath, you can go ahead, unmute yourself and ask your
Yeah.
question.
Yeah. First of all, a really nice and well laid out talk. Thank you for that. Just one question I have is, so I was interested in the sand analysis technology which you guys are using. So, what kind of software do you use for visualizing and analyzing this sand flow? And also, in the hardware and in the side, you have an apparatus with the sand configuration similar to the moon's sand. So how is that working? Like, how is that whole thing set up?
So, for the practical experimentation, we have M2 sand. It's one of the grade of sands which we can buy in the industry. It's not exactly replica of moon sand, but it's very close. It's very fine sand. Secondly, about the software, there it's Fitzroy and others. I don't know other softwares, but uh, one of them is Fitzroy for sand simulation. But the basic sand simulation you can also do in ISAC sim. or Isaac Gym or Mujoko also, but it's very computational heavy software. So you need to take into consideration that.
Got it. Thank you so much.
You're welcome.
Kuhak Das, you can just ask your question.
Yeah, thank you, sir, for the presentation. And I would like to ask that NASA is going to deorbit the International Space Station by 2030. So, will the Indian version of the space station that you talked about going to replace ISS in a few years?
So there are two aspects in that. First of all, I will talk about from the ISS aspects. So they are deorbiting by 2030, but they are not directly deorbiting it. There is one Axiom Space. They are building their first commercial space station. So they will launch that space station before 2030. It will go into space. It will dock with the ISS, International Space Station, and all the data and everything will be transferred to Exum space station, and then they will deorbit, detach it from the Axiom space, and the ISS will be deorbit. So there will be one commercial space station there up there in place of ISS from the collaboration with NASA and a private entity. Talking about Bhartiya space station, it's different, and like what all experiments it will do and how it will work and what are the collaborative partners it will invite, it's still unclear. It's just in the proposal phase that we are building, and it's not going to launch before 2030, so it will take some time.
Thank you, sir.
Yes.
Sir, as per what you said, for autonomous operation of these rovers or landers, what vision system we are using? Are we actually sticking to cameras or are we switching to LiDAR? What is the process there?
So for vision systems, either you can use lidar based system or you can go to RGBD cameras. Okay, so there is IntelliSense camera, which gives you depth also along with RGB colors, or you can basically use the lidar based thing. Both will work fine.
Okay, sir, and I just have one more question. What would be the ideal power source if we want to ensure the operation of these robots in the lunar environment? Because as we know, if we try to pack bulky batteries onto these robots, their weight significantly increase, which adds more problems and more cost. So what would be the solution to that?
So for the solution, uh, I will give you one example. Japan recently is going to test the space-based solar power transmission system. Like the satellite will be in the space, it will gather all the sun radiation, and then through microwave, it will using microwave wave beams, it will transfer the power to Earth. So in my lab, there is work going on in that also, in that field also, that we collect the power source at a place and then transmit wirelessly to the robots working in the field. So that is one of the possibility. And for the current implementations, there are batteries which the rovers needs to charge by sitting idle for many days or many hours, and then they do the work, and then again they rest, recharge their batteries, and then do the work. So this is the current implementations.
Okay, yeah, thank you. That seems to be it. Does anyone have any more questions?
Yes, hello. Hello, Ashutosh. It was a nice session. So I have a few questions about basically if we send our any satellites or any robotics equipment on lunar surface. So most previously most of the time which we use old microprocessor microcontroller technologies. So I'll have to ask which nanometer technology is mostly preferred for current robotics application, like if we are using robotics like AI algorithms and all of it in it, so it might need huge amount of processing power. So I have doubt about this key, like which technology we prefer to use.
So it's not in our hand. Definitely, if we want to use, we will go for the best. Okay, but it's not the case in this world. For example, if India wants to do some research or some navigation satellites or other things, it cannot ask like the semiconductor companies to fabricate its chips. Like there is possibility of data leak and other stuffs. They do for other things, but I'm taking one consideration. There is SCL Chandigarh, which the nanometer technology is 128 approx, I guess. So India is mainly using that technology node for now. And if we have our own technology which reduces this node, then we will use that. If we talk about NASA, they have NVIDIA and they have control over the semiconductor industry, so they can use the best technology node. In that matter, they can also ask for ASIC on a particular nano technology node. So yes, that's the advantage there. I hope it's clear now.
Okay, thank you.
Just one last question from my side. So, as um, Subhojoy asked you and talked about the power system. So, yeah, definitely, as things move forward with these robots and as more AI applications are required, I think the computing will also be increased. The computing needs will also be increased. So, definitely, cannot pack more battery packs just to solve that. So, is there any kind of research going on to generate the required power more efficiently?
In my lab, there is we are not in this field. So basically, what we do, we are handling the application aspects of space robotics and the development. Regarding your question, like there must be like Nvidia or other big companies are itself trying to reduce the computational chips as small as possible, the size of the computational chip as small as possible, and then they release it. And then we just used those kind of computers. Like there is Latte Panda, there is Jetson Nano released by Nvidia, and there are others, BeagleBoard. So we just use those directly. We are not into this field of reducing the size of computational power.
Got it. Thank you.
Thank you.
Does anyone else have any questions? Okay, so that seems to be it. Thank you, sir, for this wonderful and insightful session. Would you be comfortable if we shared the recording of this talk on our YouTube channel?
Yes, I have no problem with that.
Okay, thank you once again. To the participants, you can check out Astronova on our website and our LinkedIn page. And that's a wrap. Thank you.
Thank you all. Have a good day.
Thank you, sir.